in this problem, they have said an embankment is to be constructed with a voids ratio of 0.85. So embankment should have a voids ratio of 0.85 and the quantity of embankment is 5000 meter cube. I have noted down that information here while solving. You should not go on reading everything. Whatever one or two sentences if you read, you should make out what is there in that. So E, the voids ratio is 0.85 and embankment volume is 5000 meter cube. Means I should make an embankment of 5000 meter cube. Hope you know what is an embankment means. So it is nothing but maybe a road is being constructed or a dam is being constructed. So if it is constructed like that, then it is called an embankment. So all this soil is dumped and then ramped so that this can have water on one side, it becomes a tank or a dam, or you can allow vehicular traffic on that so that it becomes a road. So this is called an embankment. The volume of embankment that they say is 5000 meter cube, and it should have, after compaction and all, it should have a voids ratio of 0.85. So much of embankment is to be constructed. That is what is the requirement. Now the further they say there are three borrow pits available for the construction of the embankment. Borrow pits in the sense you have to bring the soil from. The corresponding voids ratio and cost of transportation per meter cube of soil is given. Means you have soil, there is somewhere a site which is A, there is some site which is B, you have to bring the soil from, and there is some site which is uh, C. I have to excavate the soil from this, I have to transport it, bring it over here, excavate from here, transport it, bring it here and excavate the soil from A and then bring it over here. So obviously it depends upon the distance and an excavation, etc. Right? So they have given here uh, the cost per meter cube for site A is 30 rupees, site B it is 16 rupees, site C it is 25 rupees per meter cube, and they have given there is an additional data voids ratio. It is not in percentage, this is wrong. Voids ratio for A is 0.95, means whatever soil that is there in site A is having voids ratio of 0.95, site B 1.9, site C 1.65. Now what is the meaning of voids ratio? Now if you recall, voids ratio E here also I have written. So the E is nothing but volume of voids divided by volume of solids. This relation we know, right? Uh, so volume of voids will be equal to 0.85 Vs because Vv divided by Vs is 0.85. Volume of voids is equal to 0.85. This is given information. Now total volume, that is volume of embankment consisting of voids as well as solids. Now total volume is 5000 meter cube because voids are nothing but air voids or water voids which can be filled or unfilled. But total volume should be 5000 meter cube. Of that, it should have voids also, solids also. Now by this relation, if I try to calculate 0.85 Vs is Vv, Vs is Vs only, and if I simplify, I'll come to know that the solids means in three-phase diagram, you know that it is solids, voids, and then water. So, if we recall again that three-phase system also here, three-phase system has got three parts. There is a solid, there is water, and there is air. But all this is void. What is solid that has to be brought from the site only. Air and water can be present directly, right? What is to be brought is solids. Now, here, what amount of solids, volume of solids required are 2702.7 metric cube of solids is required. How this is calculated? We want 5000 metric cube of embankment. Of that, 0.85 is voids ratio. That is to say, volume of voids, if I leave, if I calculate only volume of solids, it comes out to be 2702.7 meter cube of solids. Means if I bring it from A, well, how much is the volume of solids to be brought? It is 2702.7. If I bring it from B also, whatever may be the meter cube of soil, but how much is the volume of solids that I should bring is 2702. So from all the three sides, I should bring volume of solids of 2702.7 meter cube of solids. Now in doing so, how much is the volume of soil that I should pick from A or B or C? It depends upon the voids ratio of those sites, right? Okay, now we'll see how to handle that information. In site A, they have said volume of voids is equal to 0.95 Vs. In the sense, they have said that all actually voids ratio is 0.95. So with the relation E is equal to Vv by Vs, I can write volume of voids as 0.95 Vs. Now total volume is volume of voids plus volume of solids. We'll do the calculation for 1 meter cube of soil. So here what I have taken is 1 meter cube. So this is 1 meter cube of soil I have taken. The total soil that has to be brought from site A, if it is 1 meter cube, it will be consisting of solids as well as voids. Now how much is the solids that it will be bringing? Let's see. Because of this relation, I can write Vv as 0.95 Vs, Vs as Vs, and Vs can be calculated. That is, volume of solids, ultimately I will be bringing 0.513 meter cube of solids. When I bring 1 meter cube of soil from site A, I will be bringing 0.513 meter cube of solids. Now, how much I should bring? Actually, 2702.7 meter cube. So, number of meter cube of soil to be brought or required is for 0.513 1 meter cube, but for 2702.7 meter cube. So, it will be equal to 5270.3 meter cube of soil is to be brought. But if you want to bring 1 meter cube, there is a cost of 30 rupees. Now, how much will be the total cost? Obviously, you have to multiply this by 30 so that you'll be getting the total cost, right? Now, total cost becomes 1.581 lakhs. So, site A, if you choose, you have to spend an amount of 1.581 lakhs to make an embankment of 5000 meter cube. That is what is site A. On the same lines, if I go to site B now, similar analysis we shall do here. White's ratio is given to be 1.9. Because of that, volume of whites, volume of solids equal to E. So VV, volume of whites, will be equal to 1.9 Vs. And again for 1 meter cube will be equal to VV by VV plus Vs. From this, Vs comes out to be 0.345 meter cube. This is volume of solids per meter cube of soil of site B. Right, means if I bring 1 meter cube of soil from site B, I'll be bringing only 0.345 meter cube of solids. But how much is my requirement? Requirement is 2702. So number of meter cube of soil to be brought is 2702.7 divided by 0.345. That is equal to 7,833.9 meter cube of soil is to be brought from site B. But anyway, the cost of this is 16 only. So if I multiply by 16, I should get 1.253. Means the cost involved if I choose the site B is to make this same embankment of 5000 meter cube will be 1.253 meter cube. I mean 1.253 lakh rupees. So if I compare this amount with the site A amount, obviously site B is better because though it is bringing per meter cube lesser amount of solids, because of the costing, the overall cost is becoming less than the site A. Now we'll compare with last site, that is site C. On the same lines, volume of whites is equal to 1.65 Vs because they have given whites ratio. For 1 meter cube it becomes 2.65 Vs on the same lines here, whatever we have done. So Vs becomes 0.3774 meter cube, means volume of soil, volume of solids per meter cube of excavated soil from site C will be 0.3774. Now number of meter cube of soils required from site C will be equal to 2702 divided by 0.3774. It comes out to be 7162.16 meter cube of soil has to be brought from C, and cost wise it is 25 rupees. So if I multiply by 25, I am getting a costing of 1.791 lakhs. So comparing all the costs, I can say that site B would be a better choice. Okay. Okay, next problem we have here. There is a problem. The volume of an undisturbed clay sample having a natural water content of 40%. So water content is 40% or zero point 0.4 is 25.6 into 10 raised to minus 6 meter cube. Volume is so small, right? Anyway, if I write it is P equal to 25.6 into 10 raised to minus 6 meter cube, and its weight is 0.435 newtons. Weight is 0.435 newtons. Calculate the White's ratio and degree of saturation of the sample. Calculate White's ratio and degree of saturation of the sample. If specific gravity, they have not mentioned solids, but it is obvious that specific gravity of soil solids is 2.75, right? Solve the problem by first principles. Now in this case, we'll solve it directly using whatever relations that we have, and then afterwards see what they mean by first principles. Okay, now you know this diagram. It is a three-phase diagram with solids here, water there, and then air there. Total of these two is volume of whites. This is solids. total volume is V, total weight is W, consisting of weight of water and weight of solids. Now, looking at the information, they have given weight of soil, volume of soil. So I can calculate as well weight divided by volume, that is weight per unit volume, and simply you have to take 0.435 divided by 25.6 into 10 raised to minus 6 meter cube. If I do that, I'll be getting 16.99 kilonewton per meter cube. I have converted this newton into kilonewton so that it becomes kilonewton per meter cube in the sense 16.99. This is bulk unit weight. But because I know water content, I can calculate gamma D, dry unit weight, by this relation. Gamma D is equal to gamma B divided by 1 plus W. Already we have done in earlier problems similar kind of calculations. The value that we get gamma D will be equal to 12.137. If I divide this by 1.4, I'm getting this. But this is to be equated to G gamma W divided by 1 plus E, from which I can get E, White's ratio. And once I get White's ratio, I can use S into E equal to W into Z, the relation. And from here, W known as 0.4, G given 2.75, E calculated 1.22. If I calculate degree of saturation, it comes out to be 0.9, which can be put as 90%. Hardly there is any calculation and you have all the required results. But they have said you have to start from first principles or by definitions only without directly using these equations. Now we'll see from fundamentals or fundamental definitions what they actually mean. They have given water content. I know water content as weight of water to weight of solids. It's equal to 0.4. And total weight is equal to weight of water, weight of solids. I can write that. So total weight should be equal to, which is given to be 0.435. I have written there, equal to weight of water. From this, weight of water is 0.4 Ws. This Ws is as it is. From this equation, I can calculate weight of solids only, and that comes out to be 0.3107 newtons. That is weight of solids. Now using this relation, I can calculate weight of water. So weight of water will be equal to 0.1243 newtons. So I have weight of water, I have weight of solids, weight of water also. Now because we know that water's specific weight is 9810 Newton per meter cube, I can calculate volume of water also. So volume of water becomes 0.01267 into 10 raised to minus 3 meter cube. Okay, very small volume it becomes, right? That is volume of water, right? Now, again, fundamental relation that we know is um, specific gravity and not specific gravity. This is gamma, that is unit weight of solids, is equal to G into gamma W. Specific gravity is given by gamma S by gamma W. That relation we have used. So gamma S is equal to G into gamma W. G is given in the problem. Because of that, I calculate 2.7 into 9.81. So unit weight of solids only, it becomes 26.978 meter kilonewton per meter cube. Now this is so many kilonewton per meter cube. So Ws divided by Vs. Now weight of solids already I have here 0.3107, and this I have, right? This is equal to 26.978 equal to 0.317 divided by Vs. If I calculate Vs, that is volume of solids, it comes out to be 0.0115 into 10 raised to minus 3 meter cube volume of solids. But the total volume is equal to 25.6 Newton into 10 raised to minus 6 meter cube from the data. It is given in the problem. I have calculated here volume of solids. So volume of solids I have, total volume I have. Can I calculate volume of voids? Yes, it is simple. Volume of voids is total volume minus volume of solids. So this now is equal to 0.0256 minus 0.11 0.015 into 10 raised to minus 3. So from here it is clear that volume of voids is 0.0141 into 10 raised to minus 3 meter cube. This is volume of voids. Now I know volume of voids, I know volume of solids also. Can I calculate voids ratio, which is ratio of volume of voids to volume of solids? If I put them in the ratio form and calculate, it comes out to be 1.226, and it matches with almost the value calculated earlier. Now what is degree of saturation? By definition, it is volume of voids to the total volume. So volume of water divided by volume of voids. Volume of water I have calculated. Volume of water present is okay, here volume of water is 0.01267 into 10 raised to minus 3. This is volume of water. Volume of voids already found here. I can put it there. So the ratio becomes degree of saturation. This value comes out to be almost 0.9. So it matches with the value that we have already found. Okay, there we'll stop.